So, unit number 5, we work with polynomials, adding, subtracting, multiplying, and dividing. However, what we did to a polynomial applies to any function that exists. So 6.1, we focus on adding, subtracting, multiplying, and dividing functions, but we also bring in the 5th operation on a function, and that's called composition. So part of this will feel like review, part of this will be brand new. So function operations, you have adding, subtracting, multiplying, dividing. So those shouldn't be anything that's all that brand new. Now the main thing that might be different is notation. So f plus g parentheses x, that just means add the f function and the g function together. That does not mean distribute x to f and x to g. That's not what that means. F minus g parentheses x means subtract. F times g means multiply. F over g means divide. So pretty simple, self-explanatory. Add, subtract, multiply, and divide. So based off of the symbols, that will tell you what you need to do. After you find the expression, you may be asked to find the domain. So the domain, for the most part, is all real numbers, unless you have a fraction. Your domain is all real numbers unless you have a fraction. Remember, you cannot divide by 0. So if you do end up with a fraction, then you need to find out what, if anything, will make the denominator 0. So if something like that exists, we'll solve it out. If not, then our answer is all real numbers. And we do have an example of division, so you'll see how that works. Any more questions before we work through some examples? All right, so the main thing that you'll start with problems such as this is you'll be given functions to work with. So f of x equals x squared plus 7x plus 12. G of x equals 3x minus 4. So they want you to find each function and then indicate any restrictions on the domain or range. So our main concern is the domain. Main concern would be the domain. So example 1, f plus g of x. So that means you are adding the functions. So this is adding the functions problem. X squared plus 7x plus 12 plus 3x minus 4. F plus g of x simply means add functions together. Which if you add the functions together, this is x squared, 7 and 3 is 10. 12 minus 4 is 8. So there's your function. As far as the domain goes, there's no fraction to speak of, so negative infinity, positive infinity, or all real numbers. That's pretty much how you go about doing your business. let's do subtraction. F of x minus g of x, so that means you're subtracting the two functions. X squared plus 7x plus 12 minus 3x minus 4. So you have to do the problem in the order it is given to you. So if we subtract, so remember when you subtract functions, keep the first function, take the opposite of the second function, and then combine your like terms. So everything is combined and simplified there. Again, you don't have a fraction. So your domain, negative infinity, positive infinity, or all real numbers. Questions 1 or 2? Again, as I mentioned, the only problem that really doesn't have a domain of all real numbers will be division, which we're coming up to that shortly. All right, multiplication. F times g of x means you're taking the two functions and multiplying them. So if we multiply them, we've got 3x to the third plus 21x squared plus 36x minus 4x squared minus 28x minus 48. So all I did was distribute. Combine your like terms. So 3x to the third, 21 minus 4, 17x squared. 36 minus 28, 8 minus 48. You don't have any fractions, so your domain is still all real numbers. So again, just in case you didn't get the multiplication, so x squared times 3x, 7x times 3x, and 12 times 3x. That's where those three came from. X squared times negative 4, 7x times negative 4, and 12 times negative 4. That's where the other three parts came from. Last one is division. So division from a setup standpoint is actually not that difficult. X squared plus 7x plus 12 divided by 3x minus 4. So from a setup standpoint, that's it. Now, unless they tell us to do synthetic division or long division, you're not going to do it. So there's your answer, but now we have to deal with the domain. So now we deal with the domain. So remember, with division, you cannot divide by 0. You cannot divide by 0. So since you cannot divide by 0, you take your denominator, set it equal to 0 to figure out what does x need to be in order for it to equal 0. Which if you solve that equation, it's 4/3. So that means under no circumstance can you plug 4/3 into that problem. Like none. Absolutely can't do it. So since that's a restriction, your domain is x cannot equal 4/3. Division, you have to solve out the denominator to figure out what numbers cannot go into the problem. Every other time the domain is all real numbers. The only time the domain is not all real numbers is if it's a fraction. Or a square root, but we'll get into that. All right. So, questions, examples 1, 2, 3, or 4. Not seeing any, not hearing any. So it sounds like we're good to go. So we have adding, subtracting, multiplying, dividing. Those are the 4 main operations. However, with functions, there is a 5th operation, and that is called composition. The 5th operation is called composition. So composition is when you take the answer of one function and you plug it into another. You're taking one function and plugging it into another. That's what a composition is. You're taking one function and you're plugging it into another function. So these type of problems are called inside-out problems. They're called inside-out problems because you start from the inside and work your way out. So for composition can be described, represented 2 ways. The first way that I just underlined looks like the word fog. You have F, an open circle, and then G of X. Or you have the 2 functions just smashed into each other. So there's one inside of the other. So in English terms, this is called F of G of X. So that's how you would pronounce it, how you would say it. So this would mean you would take the G function and plug it into the F function. You would take the G function, plug it into the F function. So before we do a couple of examples, let me go through the interpretation of problems of this type. So for example, if you were asked to plug in a number, which you will, and my hope is that we get to a couple of examples of that. So this is f of g of 5. F of g of 5. So what this problem means is take 5, plug 5 into the g function, take 5, plug it into the g function, and get the answer. After you get that answer, take the answer and plug it into the f function. So that this is what that notation means. If you are working with a number. If you were working with just variables, or just the function itself, you take the f function and plug it into the g function. So again, you start from the inside and you work your way out. Start from the inside and you work your way out. Any questions before we look at examples 5, 6, and 7? If you have questions you need to ask, because I definitely cannot read your mind. And I'll find out one way or the other if you know what you're doing. All right, so let's give this a shot. Problem 5. So again, they give us some functions to start out with. F of x is 4x. G of x is 2x minus 3. H of x is x squared plus 4x plus 5. So those are the functions we're working with. Example 5, we have f of g of x. F of g of x. So that means we're going to take the g function and plug it into the f function. So you have f of x equals 4x. G of x equals 2x minus 3. You're going to take the g function and plug it in for x. You're going to plug it in for x the same way you would do a number. So this becomes 4 times 2x minus 3. And you need to simplify it. And that's it. Problem's over. So again, you're plugging in functions the same way that you would do numbers. Plugging in a function the same way you would do a number. If you think back to what you did in first semester, this is similar to solving a system of equations by substitution. You're substituting one expression for another. Any questions before we continue? All right, example 6. H of g of x. So h of g of x, this is the same way of it being written this way. Same notation. You're going to take the g function and plug it in for h. So your h function is x squared plus 4x plus 5. Your g function is 2x minus 3. So you're going to take the g function and plug it in to the h function. Notice that there are two x's. There are two x's in the h function. That means you're going to be plugging it in twice. You're going to plug it in twice. Most people get this problem wrong because they forget to plug it in twice. They only do it once. So if you see x twice, you're plugging it in twice. If you see x twice, you're plugging it in twice. Any questions before we continue? Then other than that, we simplify it the same way that we've done all year long. 2x minus 3 squared is 4x squared minus 12x plus 9. Again, you write it twice. Write 2x minus 3 twice, and then you do FOIL. 4 times 2x minus 3, 8x minus 12, plus 5. So 4x squared minus 4x, negative 3 plus 5, 2. Yeah, this is where knowing how to simplify now comes into play. So if you still struggle with simplifying expressions, make use of that asynchronous time to get the extra help that you need. Example 7. So example 7. G of g of x. There is no rule that says that you cannot plug a number and plug a function into itself. You can take a function and plug it into itself. So we're going to take the g function and plug it into the g function. So we're going to take 2x minus 3 and plug it in for x. There's no rule that says we can't do that. No rule that says you can't do it. So after you do it, you simplify. That's it, problem's over. Now, the one thing that I didn't put was the domains. So none of these are fractions, so your domain would all be all real numbers. So if the problem doesn't ask you for the domain, don't worry about it. But do know that unless you have that fraction in there, your domain's all real numbers. Any questions? 5, 6, or 7? to finish off our Monday, our time together, with doing some evaluating using our function operations. So, for the most part, it is paying attention to what you are doing, paying attention to what the problem is providing for you. So again, they give you three new functions, one for f of x, one for g of x, one for h of x. So it is vitally important that you pay attention to what you are doing in the problem, that you read the directions and that you don't rush, that you do not rush through the problem. So for example 8, you have f minus g times h of -4. You have f minus g times h of -4. So -4 is the number that's getting plugged in. So this is the same thing as f of -4 minus g of -4 times h of -4. Take -4, plug it into f, take -4, plug it into g, subtract those, take -4, plug it into h, and then multiply it. So my suggestion for you is to do the physical work first. Do not try to write everything in one string. Literally off to the side, actually work out these functions. So f of -4, so 5 times -4 plus 4, that's -16. G of -4, -4 squared minus 5 times -4 plus 4. 16 plus 20 is 36, plus 4, 40. And if you see something wrong in my computation, please tell me. I'm not perfect. H of -4, -1/2 times -4 is 2. 2 minus 7 is -5. So, first step, take a moment, solve everything out. So, solve everything out. So now let's work it out. F of -4 minus G of -4. So that's -16 minus 40. Times h of -4 was -5. So order of operations, -16 minus 40 is -56. -56 minus times -5 gives you positive 280. Check my calculations there. 280. So it's not a hard problem, but it is a problem that requires you to pay attention to what you're doing. Any questions with example 8? We'll do one more before we wrap this up. So example 10 will do tomorrow, or at least get one in of doing the composition. So example 9, f of g of -2. So that means you're going to take -2, plug it into the g function. Take -2, plug it into the g function, so that's -2 squared minus 5 times -2 plus 4. 4 plus 10 plus 4 is 18. So g of -2 is 18. So this actually now becomes f of 18. Now you take 18 and plug it into the f function. Five times 18 plus 4. 94. That's what a composition problem is. It's a two-step problem. Take what's on the inside, plug it in, get your answer, take your answer, plug it into the next function it's left over. You start from the inside, you work your way out. Any questions with example 9? And it's not a hard problem. It is a problem that's going to force you to pay attention to what you're doing.